All right. Are we cool for video? Cool. My name's Int80. I'm the rapper in Dualcore. Also the guy with the mustache. That's my Twitter, at Dualcore Music. We're going to talk about more anti-forensics, MoarLouise. Last year when I gave this talk, I gave a different talk, but on anti-forensic stuff, I started with a knock-knock joke. And I just gave this talk, the new talk, at DerbyCon in Belgium. And so I did the same knock-knock joke, which this is the punchline, who's there, FBI. But I started out and I was like, okay, so in the U.S. we have this thing, knock-knock jokes. And I say knock-knock and you guys say who's there. And everybody looked at me like, what is wrong with you? And then I found out from my producer, like, yeah, we have knock-knock jokes in Europe. I was like, oh my bad. But I have an email from him, and we were like talking about stuff, and he's like, oh yeah, we have Blockbuster, and then in parentheses he writes video rental store, and I was like, all right. So this is for the Louise, and I tried to run the video last year, but we didn't have audio run, so I'll run it this year properly with audio.
Imploding. Europe's imploding, and he's still banging on about this.
I hate to continue about hacking though, but the latest victim to be hacked apparently is the Sun newspaper, which its website has been targeted by Anonymous, which you might remember had links with WikiLeaks. That was before, and that's what happens when you log into it now. The Louise boat, it says. So you I don't know if it's still like that.
Who's the Louise boat?
That's what it's like now, if you click on now. So
it's
been tampered
it's some
with.
hacking thing. Who is Louise boat? No.
I don't know who Louise boat is. The group is called Anonymous, and they hacked into various credit card companies.
I mean, it's wrong. You shouldn't go wrecking websites like that. It's not funny. It's not clever. He says, "Wait till I'm done now tomorrow" for saying that, and I hope the Sun get control of it back and get their own stuff up.
Okay, lots more still to come, including why the Express says a closed-door policy on migration is the best way forward for British workers. We'll take a look at how they're covering that story. Oh, not that one. That one in just a few minutes' time.
Yeah, awesome. Who is the Louise boat? I think they kind of know, sort of. All right, so last year I had some disclaimers. I'm not a forensics professional, but I always like when people in their talks, write like, oh, you're responsible for how you use this, and if you get caught, like, it's your fault and whatever. And like I learned to do stuff by doing illegal things, so I recommend doing illegal things. I was going to say those first 3 bullet points, and then I was talking with somebody from the EFF, and I was like, oh, just by the way, like, what happens if I say those first 3 bullet points? And they're like, that's actually a felony. I was like, oh. And so he was like, I am a lawyer, and this is legal advice. Don't do that shit. So I'm not saying the first 3 bullet points. So this whole thing about anti-forensics is just trying to like raise the bar a bit and making it more difficult for forensics investigators, right? Like a forensics investigation is very resource intensive. It's very time intensive. So if you if you are a forensics investigator, you probably know your stuff and probably pretty solid. And if you're the subject of a forensics investigation, you're going to have a bad time. Like you don't want to get yourself caught to begin with. So what I'm going for is a slight modification, which is this. If I'm the subject of your forensics investigation, you're going to have a bad time. So we're going to do a couple things here. They're trashing what I've got is a tool that modifies timestamps on stuff. It's kind of like time stomping, except all my stuff is in Linux on extended 4. And we'll see that by modifying the system time, updating the file timestamp, and then restoring system time, we're able to actually touch all attributes of the file timestamp. Staying hidden, I've got a bunch of stuff messing with, what did I mess with? TrueCrypt and KeyPass, I'm sure, but staying hidden, messing with ping files. So it turns out you can stick like all kinds of interesting data in ping files, like the image format, and then extract it later on, and the ping file still renders properly. Trolling harder, I've got like some modifications and stuff that I did with KeyPass and TrueCrypt to hopefully like hide your TrueCrypt volumes or your KeyPass database, as well as making them unrecoverable in certain cases. And then easy mode, I just have a script that quickly lets you switch between using Tor and not using Tor if you're using Provoxy. I browse through Provoxy. Most of my normal browsing, I browse through an SSH tunnel, but I got tired of like modifying my Provoxy config and then restoring it and all that stuff. All right, so file timestamps. If you do like a stat on a file in extended for file system, you'll see 3 different attributes: access, modify, and change. You can actually do that right now. Oh, that's a shout out for Egypt from Metasploit. He and I were talking online one day, and he was like, "You got to work a bash.org meme into your thing," and I was like, "Okay, I'll have something with disregard that." Anyways, so we can see here we've got 3 different timestamps, right? Access, modify, and change, and I've already been messing with this file. So this file was accessed, modified, and changed in 1989, apparently, before backtrack was even a thing, or extended for. All right, so if you go to like update a file timestamp, you can do certain attributes using touch, but the change timestamp doesn't get modified. And so like obviously like that would be kind of a tell, right? Like, oh, we have these files where, you know, access and modify are the same or different or whatever, but like the change one is the original. That might kind of give you away if you're trying to keep something hidden. So I was like, how do I update this? So my solution was to modify the system time, like I said, update the file timestamp, and restore the system time, and that lets you actually hit all 3. And so to do that, I wrote this tool called Look at All the Fields I Know. So we'll just run it against the same file. And now we notice that we have access, modified, and changed to 1998 instead of 1989. So it just picks a random timestamp, changes the system time, and then hits the file. It takes one file in as an argument. The reason that that I run it in the VM, like I wrote on the slide, demo in VM, please, is because I had something kind of funny happen. If you run it as like if you fork out a bunch of these processes, like let's say you want to hit a bunch of files all at the same time, or like all the files on the system, you get a lot of interesting results, like trying to set the system timestamp simultaneously to like different dates, different processes doing that. This is the code of the script. It basically stores off the current time, generates a new random timestamp, and then updates the file timestamp that you passed in, and then restores. So this is the find command that you can use. Like you can pass it a directory, like instead of find dot, if you were like find, you know, /varlog or something like that, like /user, whatever, like whatever directory you want to pass in, and it will fork out a bunch of processes for you, modifying all the timestamps of all the files. So you get like funny results, like if, I don't know how well that shows up, but you could like there were, in this case in the process listing, there were 3 date processes running. One was trying to read the current system date. The second one is trying to modify the current system date to maybe the year 1440. And then the other one, another process at the same time, is trying to modify the system date to the year 2325. So it's kind of funny. You can have like, you know, all kinds of fun stuff going on. So if you do it in serial, one file at a time, it's correct. You'll end up at the right point where you came back. If you do it in parallel, it's really fast, but you can have craziness happen where like you're setting different dates all at the same time. I guess at the end you could, like, to deal with that, if you wanted to hit everything in parallel, you could just sync up, do like an NTP or query out, and like restore the system time via that. The other thing with stats is that if we go back and look at the timestamp, we notice that like the nanoseconds are like uniformly always the same whenever you whenever you modify a file, like with this. Like I don't have a way to update or have any control over the nanoseconds, so you're always going to have like this 0000 or 0001, where that was like let's see, I'll just stat something else. Like that's not the case, you know, with a normal file, right? Like you can see the nanoseconds here are some number that's not 0. So I'm sure that this tool like exists somewhere. Like I just haven't ever seen a copy of it. So that's why I wrote one myself, and I'll push it up to GitHub. Yeah, it's not like lead hacks or anything. But funny work anecdote. So I wrote this tool, and I come into work one day, and I'm like, oh, yeah, I wrote this tool, like, and it, here's how it works: pushes system times, touch file stamp, and then restore. And then the manager in the office, he comes in, and he's working this investigation, and he's like, oh man, these attackers, what dicks? He's like, this guy changes the system timestamp, then he updates the file timestamp, and then he restores the system timestamp. And like everybody stops and looks at me, and they're like, he just wrote a tool that does that. Like, oh, they're like, are you hacking our clients? I'm like, wait, which one is it? I don't know. Any questions about the timestamp stuff? Yes. Yep. So the question is, isn't that like a giveaway when you see a file where like the milliseconds and nanoseconds are all zeros? And it is. So like one of the ways that you could use this is you could say like, all right, screw this system, like I'm out and I'm just gonna like blow everything away, and you could run that against every single file. And so that way, if you're like recovering logs and you're trying to look at like what time a particular file was accessed, all the file timestamps are off, and so like you're just in a mess anyways. Like everything's wrong, and so if everything's wrong, nothing's right. Okay, so staying hidden. So I always love like random places to put your stuff. Like when I started doing like web app security when I was in college, like file inclusions were hilarious to me. I was like, oh, like I can cram PHP code into an EXIF header in a JPEG file and like still get my PHP code to execute, Like that's always hilarious when you get stuff in places where you're not expecting necessarily. So my Brule Corey stow with this one is wow, I hacked so hard. All right, so I'm on this SANS mailing list. I have one cert. It's a SANS reverse engineering malware cert, and like if you score like above 90% on the cert, you can like get on this mailing list. So this lady on the mailing list one day, she sends this email and she's like, hey, I saw this thing about PE files, like malware PE files being embedded in ping files. Does anybody have any samples that I can practice with? And I go, I've never even heard of this, but I'm sure like, all you need to do really is find the like PE header, like the MS-DOS stub, and like extract it out. So I'm like, I bet I could make one. Like I can put some malware in a ping file, like no problem. I bet I can programmatically do that too. And so like I write this program that does this, and I take some malware and I stick it in a ping file, and then I reply with just the ping file. So like I think they think I was being a dick, but like in reality, I mean there's malware in there. Like I was trying to help. Like there's the MS-DOS stub, and really all you need to do is just DD from that offset, and the data structures in the PE format like take care of everything else. I mean there's the PE header, like so I was just like not sure if serious. So the whole thing was programmatically embedding your data into ping files, and so the way that ping files work is they break down into chunks, and there are two categories of chunks. There's critical and there's ancillary. And so critical is like critical to the rendering of the file, but ancillary is kind of like metadata. So if you have an app that's trying to render a ping file and it goes to process an ancillary chunk and it doesn't understand it, like it doesn't understand what a PE file is, it just doesn't care. It just goes on. So fucks given is literally zero. You just XOR fucks given against itself and you get zero fucks given. So problems, right? Like I showed you guys, like there's the MS-DOS stub in that ping file. Like I can DD it, pull it back out. Like that's my malware. Now you have collected my malware, and my whole thing is like I'm trying to hide my malware from you in this ping file. So one of the ways that I address this problem is splitting the file. There are a number of different types of ancillary chunks. So you can like split the file across multiple ancillary chunks, throw them in the ping file, and then like extract them back out and put them together. Another thing I did is like, okay, fine, like if you have like all the chunks, you still have all the data from the ping file, like all the bytes, or all the from the PE file rather. You still have all the bytes of the malware. So I was like, oh, we can just transform it with like a one-time key or a one-time pad, and then that way, like, you have to figure out like what my key was. So that kind of helps keep the malware hidden. Also, like, if I just throw like, a 100K piece of malware into a ping file, like, you might see like, oh, there's this 100K chunk or like a 50K chunk, which may be statistically an anomaly. So this tool, Hello, Yes, This is Dog, it has the ability to generate a random number of chunks and also a random size for each chunk. So that way you don't get like a uniform output, like it's not always like your PE is always in this one type of chunk or whatever. Like, just try to make it as random as possible so that there's not much consistency and you can't programmatically find like ping files that have malware in them. And then the last thing is the position of the chunks, right? So initially, like, I was just throwing all my ancillary chunks at the back of this. I was like, oh, if I find a ping file that's got a bunch of ancillary chunks at the back of it, like spider sense might be tingling, and we check into that ping file. So we can randomly mix and rebuild the order of the critical and ancillary chunks. The ping renderer will still process the file just fine, and it's awesome. Like, it still shows as a normal image. This is obviously like a later stage, like, anti-forensics technique. Like, you've been on the system, you've got malware there, and you're just trying to keep it hidden so that it doesn't get analyzed by someone like me. Oh, and hello, yes, this is Dog. All right, TrueCrypt stuff. Sorry, any questions on the ping file stuff before we move on? Yeah, sorry, in the back first. Yes. So the question was, could you use different file formats? And yeah, absolutely. Like, all you have to do is just look at how the format is composed, find somewhere where like you can stick your code, and like you're off and running. Yep. Yes. Yeah. So the malware doesn't. Sorry. So the question is, if you're randomizing the injection of the Windows executable file into the ping file, how do you make it so that the Windows executable is still usable? The executable doesn't run on its own anyways. Like, you would need something, some kind of tool to extract it from the ping file. And so this does both the embedding and the extraction for you. And so that way it can also do the reordering and like the transform, like decoding it and stuff like that as well. Exactly, yes. The question was, you would still have to use your one-time pad in order to extract, like, the same one-time key that you use to embed. You'd have to use that to extract, and that's correct. Once it gets extracted, you would be passing in your one-time key as well, and it would decode the binary, and then you're off and running. Cool. All right. So messing around with TrueCrypt volumes. Last year at the talk, I had demoed an MBR that I had written. Since I boot off of removable media, I have one encrypted partition on my hard drive. And so if somebody like a TSA agent or whatever just tried to boot my laptop off of a hard drive, my custom MBR would run and overwrite the encrypted partition with trollololololol and destroying the encrypted data. So I kind of did the same thing here with TrueCrypt. It said, like, what if, like, the situation is like, what if I'm like going through the airport and TSA pulls me aside and takes like my TrueCrypt volume off my USB drive, and they say like, here, decrypt this. And so like I boot my laptop and type in the wrong thing and destroy the TrueCrypt volume header, but everything looks normal. That's what I'm going for. So it turns out the TrueCrypt volumes actually have a documented header. Like, if you go on the site and read, like, you can see like at certain offsets and stuff like that, certain attributes of the volume are there. So basically, if we overwrite that header, we can't decrypt the volume. So I wrote this patch for TrueCrypt. It's called Gooby Please, and it wipes the header if the wrong password is given. All right, so this is my patched TrueCrypt binary. And then I have, this is my TrueCrypt volume. And I'm going to mount it in this directory called TC. I'm just going to show you that like it works normally first, and that there is stuff in the TrueCrypt volume. So that's normal operation of TrueCrypt. Ask for password, key file, and then ask if you have a hidden volume. And then if we ls tc, like we see that there's stuff in there, right? So, all right, and if we look at the header of the volume real quick, like it's a bunch of random data, right? All right, cool. Okay, so now if we run my custom version, again, of TrueCrypt, and instead of using the password as Tor, we just type something wrong. Everything looks normal except, oh, incorrect password, no problem. And if we and so yeah, now there's that header is gone. Yeah, it's gone. All right. This is the patch. It's just some C++ code. Not much to it. The options object just has a data member called path that contains the path to the volume that's being passed in. So we just basically dereference that, grab it, set up our string of trollololol, and one important part is we open the file with iOS in and iOS out, and obviously iOS binary because it's a binary file, but iOS in and iOS out so that we can write in place. If you open it with just iOS out, it will truncate the file, which I mean could be fine too. I mean you would get rid of or like unlink the encrypted data, but like they would see that the volume size changed and maybe be more suspicious. I don't know. I mean, overwriting trollolol is pretty obvious anyways, I guess. But yeah, so then we just overwrite the volume and close it out like good C++ programmers that we are. So I really like, has anybody here read the book A Bug Hunter's Diary? It's cool. Like it's the author basically, he details like exploits that he's written, but he kind of gives you the anecdotes. Like I started here and I found this, and then that took me to looking at this and whatever. And I really like that format. So if anybody wanted to like mess with TrueCrypt and stuff, this is kind of the process that I went through. If you remember, like in the original like running of the program, it asks you like enter password for your volume. So I just like grepped like enter password for, and then like across the source code, which brought me to like the file to patch. And then in my head, I'm thinking like, okay, I want to destroy the volume header on the first entry of the incorrect password. So fortunately, there's a variable in there called incorrect password count. And then in going to compile, like I got some complaint about PKCS11 stuff. So this is the URL where you can get the PCKS11 header files, and you'll just need to export that path so that they can be compiled in and linked in. These are some packages that I need to install: libfuse headers, package config, WX base headers. WX is like Windows widgets. I don't know why I needed it for a console program, but TrueCrypt wants it, so you have to give it to it. And then this is the make flags that I passed in so that if I wanted to debug it in GDB, which does anybody love GDB? Wow, you guys love pain. Wow. All right, so it's like one of my friends who works on a very public application that everybody uses. He's like, yeah, when I get a bug report for Windows, I'm like, cool. When I get a bug report for OS 10, I'm like, and then he's like, when I have to use GDB, I just go cry in the corner. But so compiling with no GUI, of course, is going to give you a console program, debugger 1, and then no strip is important so that you get your symbols, so you can quickly like set breakpoints on like your variables and stuff like that if you want to try to trace into something very quickly. The TLDR version, like you guys saw this last year, some of you, probably don't need all this stuff, right? But my TLDR version of all this is I have like this hilarious backstory with the FBI where I like met Cyber Special Agent in Cincinnati where I used to live, and it was just like hey, I'm David, nice to meet you, and left. And then like 6 months later, I saw him at a baseball game and didn't remember his name. And he's like, oh, I'm Dan. And he's like, you're David. And then he says my last name. Like, oh. So, and then, yeah, and then sometime after that, I don't remember how long, our neighbors across the street moved out and new neighbors moved in. I went to go say hi and meet the new neighbors. And it was the cyber special agent from the FBI. FML in caps. Yeah, and now I live in California. So basically, like this incident, Axiom incident, these kids that were part of 2600 got arrested in 2003. I didn't know about it. Cincinnati 2600. And then around like 2006, I started giving prezos at Cincinnati 2600. And all my stuff was like, here's how you write exploits and here's how you hack into stuff. And after I learned about this Axiom incident, this is when I started to kind of get paranoid. Like, oh, I bet like FBI bros come to the 2600 meetings and they probably, you know, I'm on like a short list. Like, oh, all right, so there's this one guy who's always giving these talks about writing exploits. Like, it's probably me. So these are all warning shots. Like, please don't come take my stuff. Like, it's going to be really messy in there. Rooting tail trap. Cool story, bro. Any questions about TrueCrypt stuff? Yeah, in the back. Yeah, okay, so the question is like having like a bad, like specifically bad password, as opposed to like, oops, I, you know, fat fingered my wrong key and like there went my volume. Yeah, that is something that you could do. Like you could definitely add that into the patch and like have a specific password for sure. And then you could obfuscate that as well so that, you know, if they tried to like run strings against it, against the TrueCrypt binary and see like, oh, if he types this in, whatever. I just don't mess up when I type. No, I don't. I don't keep anything special in TrueCrypt volumes. Lots of horse porn. That like, hey, you wanted to see what was in there. That's what you get. All right. So KeyPass database. KeyPass databases, like lots of files, have specific and defined header bytes. You know, magic numbers, or they're called sometimes. So these are the bytes, right? So if you're conducting a forensics investigation, you know, KeyPass database could be a high-value asset. Like, I don't know any of my passwords, so if someone's like, oh, I need to get access to all his accounts or a specific account, like that VPS in Luxembourg or whatever, you know, my SSH key password is like in that KeyPass database. So if you crack that KeyPass database, you've got the keys to the kingdom. So my premise is, don't get my KeyPass database found. Like, if they can't find it, then they can't crack it. So, you know, I would assume that at least one forensics investigator would let NCase like run over it and be like, oh, I didn't catch any KeyPass databases. Like, I guess there aren't any. So if I can change these bytes, like this is how NCase finds, or like forensics tools, Scalpel, FDK, whatever, this is how they find the KeyPass files, by looking for these header bytes. So if I can change those bytes, then you know, that it's not going to turn up. So I wrote this patch for KeyPass. It's called isDolen, and basically we just change the header bytes that a KeyPass database uses. Did anybody see my talk from BrewCon the other day? I think it was streamed, but did anybody see it? All right, cool. Then you guys are all eligible for a dual core wrap CD giveaway. But you better break your laptops out, or at least it'll probably help. All right, so this is the patch real quick. Like in the first couple lines, those are the main header bytes, right? Like we saw 03 D9 A2 9A 03 D9 little endian. And then the new header bytes for my custom KeyPass version are the last two lines. So for a free dual core, all the things, #1 selling album on Bandcamp, album, what is the ASCII printable string of the new header bytes for KeyPass database, my custom KeyPass database? Yeah, I heard it in the back right. Who yelled it? All right. Come get your CD. Parkour. At 10 something in the morning. Oh yeah. So all right. Let's take a look at my normal. Oh, why you know? I'm sorry, what? Oh yeah, I don't mess up typing, right? All right, so again, here are the header bytes 03, D9, A2, 9A, like we saw. And then in my custom version, so like if you're carving looking for those header bytes, they're not there, so you don't find it. So one of the caveats, not immune to normal IR stuff, right? So you see that like this file was accessed at the same time that KeyPass was loaded or whatever. So that could be one way that you get thrown off or that you get caught. If you name your KeyPass database with the .kdb or .kdbx extension, that could be a giveaway. KeyPass also has an option to set, like, is this your favorite KeyPass database that you use like all the time? Like, I have mine set. You could say like, yeah, don't do that if you don't want it to like be obvious. And also, like, if somebody REs your copy of KeyPass, they can see like, oh, these are the new header bytes. Hopefully, I don't think most forensics investigators do reversing, so I don't think they'll reverse your copy of KeyPass. They'll probably reverse mine, but so I put IDA exploits in my KeyPass. No. Any questions on KeyPass database header stuff? Okay. So more messing around with TrueCrypt volume stuff. So I asked some forensic bros that I know, like, hey, how do you go about finding TrueCrypt volumes? Just for no reason, just wondering, just curious. So they go two ways. Number one, they conduct entropy. They do an entropy analysis of a file, and if it has very high entropy, that is a candidate for a TrueCrypt volume. And also look at file size. So I did some testing. I was like, what is the entropy on like TrueCrypt volume? So I wrote some source code, which I'm not planning to push to GitHub, but if anybody wants it, like, you can email me. I'll happily give it to you, to randomly generate over 9,000 TrueCrypt volumes. And random sizes, random file contents, and whatever. It's just as random as I can be. And like it turns out, like I did Shannon's entropy on it, and is like the maximum value for the entropy on each volume. So maybe I did the wrong stats. I don't math very hard, so yeah. Anyways, so I was like, all right, how can I beat the entropy? Like, how about I just put a lot of non-random data on the TrueCrypt volume? It actually works out really well. The cool thing is it doesn't matter. Like we talked about the TrueCrypt header before, all of that is internal data structure saying like the volume is this size and like the keys are here or whatever. So like you can throw whatever you want on the back of the TrueCrypt volume and TrueCrypt it'll still work, like no problem. So I wrote this program called Bogs Please, and it's basically just appending non-random data to lower the entropy. Like you throw a bunch of zeros on the back of a TrueCrypt volume, take the entropy of the entire file now, and it's like way less, like way lower, because you've got all this non-random data appended on. I'm not going to demo because it's we're short on time, but I'll just show you the source code real quick. So we just check first, make sure that we have a file. Also, since we're going to be appending, I'm using the IO redirection with the double greater than signs. So if you're root, that's probably preferable. So basically, this main block here of the while loop is like randomly appending a random amount of zeros onto the back of this TrueCrypt volume. One thing I did is, since BrewCon, is I added on a random extra amount of random data. So you'll have like your TrueCrypt volume, then you append some random data, and then you append a bunch of zeros. And that way, like, if you saw these big files, right, because that was one of the things, file size. If you see these big files where there's a bunch of non-random data at the end, you say, like, oh, I'm just going to carve up until that non-random data, and then, like, that's the TrueCrypt volume to, like, start working on, start brute forcing. So I figure if I put a little more random data on there, maybe they don't, like, extract the right amount, or, like, maybe from the wrong offset or something like that. It probably doesn't really matter, I guess, in reality, because because of the data structures in the TrueCrypt header. I don't know. I was drunk on the plane, and I actually wrote a new version, accidentally deleted it, and rewrote it, and it was just whatever. So anyways, it's like 3 p.m. on next Tuesday for me right now, because I've been in Europe all week. So, all right. So problems. Yeah. All right. So we've got a bunch of non-random data at the end, like that could be something. if you like, you could probably programmatically find that. And increased file size, right? Like that was one of the attributes, like, oh, like big files, candidates for TrueCrypt volumes. And we actually didn't help that at all. We added a bunch of data at the end. We made the file bigger, but we'll talk about that in a bit. Okay. So just stringing along the investigator is like one of my things, right? Like last year I had the scripts that like would generate a bunch of stuff to be carved. Like you could generate a bunch of encrypted volumes and then like not be able to decrypt them and leave a horrible trail. So in messing around with having a trail and trolling the investigator along, I have this like this other thing. So my whole thing is like make an archive with a KeyPass database in it and a copy of KeyPass. So like, and that make the archive like easily crackable. So like, say that you've used the isDolen script, you've got you've hidden your regular KeyPass database. So the investigator is on your system, they find KeyPass, but they don't find the KeyPass database. So what we do is we generate a new KeyPass database. We make an encrypted but crackable archive, so we use like a dictionary word to encrypt the archive. And inside is a fake KeyPass database, a copy of KeyPass, and a fake key file. So that way they're like, okay, I've got the 7-zip file. Oh, I cracked it. Oh man, there's a KeyPass database in here. Like, all right, this must be it. And then they work on that, but it's actually just a fake KeyPass database. And meanwhile, that keeps them away from your real KeyPass database. OP will deliver is the name of the script. True story, bro. Yeah, not much to it. A little bit of config, pointed at your word list. Make a prefix for your archive name. Make a fake database name. Make a key file. And then this just grabs your copy of KeyPass for you that's on the system. This is a function that creates your archive. It randomly selects whether it's going to generate a 7-zip archive or a RAR archive. For another dual-core album, does anybody remember from last year why I was doing encrypted 7-zip and RAR archives but not zip archives? Yes. Yes, the reason is because on an encrypted zip archive, you can see the file names that are inside. Come get your dual-core album. I am not going to be jumping like that at the show tonight. Okay, maybe I will. All right, I will. All right, I will. I promise. At least once. So this is our header bytes for the original key file database signature. So basically, we stick a header on a file, we put a bunch of random data behind it, we make a new key file, and call it a day. Encrypt it all with a crackable password. So it leaves a trail, and now they found a KeyPass database. Any questions about that? Nope, there's actually nothing in it. It's just random data. So like, if you look at most KeyPass databases, what you're going to see is like the header bytes, and then a bunch of random data because it's all encrypted, right? So like, there's our, these are our header bytes, and then there's like, none of this makes any other sense, right? It's all random data. So it's the same thing, like, except our random data that we put on this fake KeyPass database doesn't decrypt to anything at all. Yes? Like, as entries into the KeyPass database? Yeah. Okay, yeah, so basically the question is like essentially populating another KeyPass database with fake info, right? Yeah, the reason that I didn't do it is because that just takes more time. Like, I mean, it's a fake KeyPass database anyways, so like you can spend as much time as you want cracking this. It doesn't actually decrypt anything ever anyways. the anti forensics talk. So kind of the same thing with TrueCrypt volumes that we just did with KeyPass. Like, oh, I found TrueCrypt on a system, but I didn't find a TrueCrypt volume. Like, the entropy analysis did not, show me anything. Maybe I found a big file, but like when I looked at the entropy, it was way low, so I disregarded it as, not being a candidate for a TrueCrypt volume. So we do this exact same thing, generate a fake TrueCrypt volume, which is just all random data, a fake key, copy in a copy of TrueCrypt, put it in an archive with an easily crackable password from a word list, and we give a shout out to Bruce Potter. Yeah! So, and I just called that one "You Mad Bro." Again, it'll be up on GitHub. Okay, so last thing that I got is easy mode. Like I said, I browse through Provoxy, right? So I point SSH tunnel at my Provoxy. It does like some ad filtering and stuff for me. But then like when I want to browse stuff on Tor or through Tor, I have to go in manually, change my Provoxy config, restart Provoxy, and then when I'm done browsing through Tor, I have to go in, rechange my Provoxy config, etc. So anyways, it's kind of a pain in the butt, so I just wrote this script that does it. It's called Did Someone Spider-Man Thread, and it stores the current Provoxy configuration, switches it out for you, and restarts Provoxy. I'll just show you the source real quick, because there's not a lot to it. So you point it at your Provoxy config, it creates a little local directory for you to like store off your setting. Calls out to ifconfig.me so that you can get your current IP, and it'll print out like, all right, here's where you're currently coming out to the internet from. And then, so if you give it yes, like someone did say Spider-Man thread. So did someone say Spider-Man thread? Yes. It will change it out for you and get you set up to start browsing through Tor. And then if you did not say Spider-Man thread, no, it restores your original settings for you. So it's kind of nice. At the end, like each time it makes a change and restarts, it tells you like, all right, this is where you're coming out to the internet from. Like this is where you were, this is where you are now, and so that way you're aware of what the setting is. Oh, and then another thing you can do to make it easier is like set an alias in your like bash RC or your bash aliases file, and so you could just say start using Tor or whatever, stop using Tor. Any questions about any of the stuff that we've talked about up to this point? All right. Oh yes, yeah. I just wrote my own in C, like because it's really easy to write Shannon's entropy. The question was what's your favorite entropy analysis tool? And like it's trivial to write it in C. Like I have source code right here actually. So. Like this is it. With comments, it is 108 lines of code, and that's not even lines of code. That's spacing and pretty comments and whatnot. So there's not much code, and that's some of that is like file checking stuff, sanity checking. So yeah, it's easy to write your own. I just wrote my own. But again, like I was saying with the TrueCrypt stuff, like I probably did the wrong. Like I did Shannon's entropy. Probably should do a different statistical test, but I don't math very hard. So other stuff you can mess with. Log tampering is always fun. Like IR folks like rely on logs to figure out like what's going on. So if you get in there and like modify stuff, like maybe switch out your IP with somebody else's IP, like the IR investigators workstation IP, or something else, like mess with the logs. Like that's always fun. There's tons of lulls to be had with compression. Has anybody seen 42.zip? It's in Iron Geek's Prezzo. But basically, somebody took a ton of A's, like it's all A, and you compress them down, right? It's uniform data that's not random. You compress it down, it compresses really well. When you start extracting that, it gets really, really big, really, really fast, but it starts out really small. Same thing with PDF streams. You can like utilize compression in PDFs and blow them out huge. And then there's a ton of fun to be had with Windows PE files doing anti-memory forensics, which is probably where I'll be going with the next talk. And as a bonus, you can do anti-reversing stuff with it as well. I know we got started late. We're late on time, so this is all the sauce. And check out the How to Exit the Matrix paper. It's fun. Google it. It moves around on internet. I'm at Dual Core Music on Twitter. If you have any questions or want to talk about stuff, hit me up. And then also always refer to the Sky News computer security experts. They will one day find out who the Louise boat is. Thank you guys. My name's Kah and Adrian. I'm the rapper in Dual Core. We'll be here tonight for Rap Musics at 10 p.m.